So for this problem, we have the final velocity is equal to 9.0 meters per second. The mass is 65 kilograms, and the change of y is 5 meters. And we want to find out how much work is being done by the friction as the skateboard goes down the ramp. So we have here the change in kinetic energy is equal to the work done by gravity minus the work done by friction. Well, we know the work done by gravity is equal to mass times the gravitational force times the change in y. And then we know that the change in kinetic energy is equal to 1/2 times n final velocity squared. And we know that because that's a standard formula. Now, we also know that we can rearrange this formula to find the work done by friction, which is good because we already have the value that we can replace for work done by gravity and the change in kinetic energy. So we replace the work done by gravity with mg, or mass times gravitational force times change in y, minus the formula that's equal to k. So right here I just factored out the m, which I just think makes it look better. And here, for work done by friction, I just plug in the values, just the 65 times kilogram and the 9.8 meters per second squared, which is the gravitational force, times 5 meters minus 1/2 times the final velocity squared. And then that comes out to be 552.5 joules. And that would be the total work done by friction. So just to go over again really quick, we want to find out the change in kinetic energy, so we make this formula. And the main thing in this problem is figuring out what these values are, which we know in the y direction we have the change in y, which is the height, and we know that we have the mass times gravitational, so we know that is the work done by gravity. And then we know what the formula is for the change in kinetic energy, so we can just use that and just rearrange the change in kinetic energy equal to work done by gravity minus work done by friction, and just plug in our values, and that's how we get the answer.